All right, great. Thank you, Mark. Good morning, everyone. Very excited to have this opportunity to speak with you all today and tomorrow about mathematical fluency and how to support that and things that are important to consider. I think it's wonderful that we have this many people out on a June morning. It tells me that there's a lot of concerned folks interested in fluency and maybe how to better address it with their students. To give you a little background about myself, I am a professor at Penn State. I was a middle school and high school math and special ed teacher. So I was one of those weird math persons that double majored and also was in special education. My father was a school psychologist and was very influential in sort of encouraging me to dig deeper into kids with learning disabilities. And I really got interested in this idea of how, there's two kids side by side. One student has a learning disability, one doesn't. They're hearing the same instruction, the same examples, the same everything, and one is getting it and one isn't. And, it's frustrating. I think everybody would agree it can be frustrating at times, but that was very interesting to me. Like what is happening, and more importantly, what can we do to support that? So that's my background. I also have a math degree, so I really approach things from a content perspective as well as a learning and an instructional piece. And we're going to talk about fluency today. And there's a lot of conversations going on at various levels about fluency, what it is, and there's a lot of just sort of misunderstanding, opinions, and it's hard for teachers to filter it. And then figure out what to do. So that's what we're going to really kind of dig into today. Now, this is a large group, so again, like Mark said, make sure your audio is muted. If you have questions, you can feel free to throw them in the chat. I'll try to monitor it. I think Mark, if you see something in that chat,
I'll be monitoring it.
Yeah, make sure I catch it. There are going to be some times where I will purposely say, okay, let's stop. Let's have some questions here. So that will run throughout. But if something pops up, feel free to unmute and ask a question. We'll kind of move through it. It's always hard to judge how fast these are going to go. Sometimes larger groups, they go faster because people are less likely to ask questions. Sometimes with smaller groups, it take a little bit longer. So we'll just sort of play it by ear. We'll take a break at some point, 15-minute break here to get everybody stretch, get some coffee, fresh air, and then we'll move forward. So Mark, you should have a set of materials in a PDF, and then there was an article also that I included in there. So here in a second, I'll be showing my screen. If you have those materials, either paper or electronically, that's fine. And then we'll kind of move through the district. Before I get started, it would also help me if I kind of had a general idea of grade levels. So if you are a teacher in grades K to 5, give me a thumbs up emoji down in from your reactions, just so I can see where we're at here. So K5, thumbs up. And I would expect to see quite a bit of thumbs up. Okay, all right. Okay, how about middle school? So usually that's 6-8 or even 5-8. And give me, let's see, let's do thumbs up with that. So middle school, okay. High school. Couple high school. We know how high school teachers are. Couple high school teachers. Okay, all right, good. That's good. Now let's, if you teach special education, give me a thumbs up. I'm interested to see at any level, special education teachers. Good. Just so non-special ed. I know you have kids with disabilities in your classroom, but if you're a sort of a general ed teacher, you give me a thumbs up on that. Okay, good. We got a nice mix in here. And then I'm sure I have some district, maybe building principals in here, curriculum folks, coordinators, directors of special ed, things of that nature. So, okay, good. That gives me a good sense. So when we get into fluency, when we get into the actual strategies, the techniques, regardless of your grade level or whatever the content is, the design principles are going to be the same. So even if you're trying to have kids become fluent on something in chemistry, for example, or sight words, there's just a lot of overlap across the board here. So I just want to keep that in mind, that we're obviously going to be focusing on mathematical fluency, but there's a lot of overlap in terms of how you approach doing this. All right, so with that said, I'm going to share my screen, make sure I share the right screen. All right, so is everybody seeing my PowerPoint? All right, good. A couple weeks ago, I talked for 15 minutes and I thought I was sharing my screen and I wasn't. So I still have sort of PTSD from that experience and I have to double check. All right, so like I said earlier, we're going to focus on developing mathematical fluency through purposeful and targeted practice. So that's going to be a theme that is going to be a big part of our conversation today, is this idea of purposeful and targeted. And we're gonna go to a whole nother level of what that means in terms of practices. Now, I kind of lump this in. Some of you have seen me. I was there. Was it last summer? I was down in. So I was there last summer where I did more of a comprehensive session. Fluency was part of it. Today we're just zeroing on fluency, but I kind of call these high intensity instructional techniques, or HIT for math, a play on the CrossFit world that gets all the attention, and that we're taking things that you already do. So there are practices I'm absolutely confident that you're already doing. They're either built into your program or things you've developed over the years. So we're going to be taking kind of that as the foundation and trying to make them more intensive. I'm not one to say throw it out, get rid of it, it's bad. There's very little bad things we do in education. There's things that are less effective and more effective, but there's not bad per se. So we're going to be taking what you're doing. So as we're starting to ramp up, get our brains thinking again, think about fluency in math and start thinking about what are the things that you do or have been doing, or maybe you did, but you're not doing them, sort of trends. We get momentum and then we lose it. We change course, but start really thinking, what is it that we're doing, I'm doing, or I see happening related to fluency? And that's going to kind of be the driving piece here. But before we get into that, probably the biggest misunderstanding about fluency is why we do fluency. And we're going to spend a little bit of time up front talking about the why piece, because the why piece here is critical in terms of how we do this more purposeful practice. But in the next couple of days, we're going to kind of really dig into this idea of why do we have to do fluency? And then what are the elements that have to be in fluency practice, no matter how you do it? And that's a nice thing. There's a lot of different ways to do this, but there are certain core ingredients that have to be in that practice, or it's not really addressing the fluency piece. And then we're going to get into 4 specific techniques that we will walk away with today. Today and tomorrow. So I really hope that when you leave here, you will have a more complete and deeper understanding of why we need mathematical fluency, and cognitively why that is important, and then how to actually address it, either through these 4 specific techniques or adjusting things you already are doing in your particular classroom. So that's kind of our general focus for our 2 morning sessions. But before we get started, we've got our little friend here, the 900-pound gorilla. This is actually, fluency is one of these things in education that is literally the 900-pound gorilla in classroom, in math right now. And what I mean by that is teachers that have been teaching a while, they know its importance. Special education teachers who are working with struggling kids see it firsthand, but there's just this big debate going on about what is it, why we don't need it, et cetera, et cetera. And, you know, time tests are bad. So that's the latest big thing, like no timing. Timing's terrible. It's going to be detrimental to kids. So there's that piece that's out there. Some people say it's old school. Yes, you know, that's that like old math, old new math, old new reform math, all those kinds of things. The standards, it is in the standards. I'll talk a little bit about that. But I just wanted to acknowledge that there's a lot of varying opinions on this. So one of the big things that I like to sort of emphasize is, you know, there should be some school level or grade level conversations around fluency. If you don't have those, then you have individual teachers and their opinions and positions sort of driving it, and you get classrooms that are just very, very different. So a big sort of takeaway from today is if you're here with a group of your teachers, or you're here by yourself, or you're a principal or a curriculum person, you really should have some broader conversations about fluency and the position that you're going to have, and then start thinking about what you're going to do. But I just wanted to recognize that this is a big, big debate in terms of you've got NCTM and their position on it. You've got neuroscientists, cognitive folks, special education people, but then you also have mathematicians and sort of their take on it. And those are very different groups. So just understand that this is an interesting topic right now that's being debated in our education. But one of the things that my work with teachers is that I've really learned is that teachers know that it's important at some level. They see kids struggle, and they know part of their struggle is this fact issue, and they're not really sure how to do it, and they're hearing all these different messages. So teachers generally have this understanding, like, I know it's important, but I'm hearing this, I'm hearing that. What do I do? And it's sort of left teachers in this sort of flux. So there's that kind of piece there. But then so the core math program. So I want to talk a little bit about the core. So when I say core, I'm talking about whatever program your district identifies as your core material, your math program. So it may be a book, it may be a basal series, it may be an online, whatever it is, whatever is sort of driving your instruction. We know that core programs have some inherent weaknesses, all of them, because they're all basically designed the same way. But one of the inherent weaknesses that's embedded in programs is this idea of fluency practice. That is a weakness. So that's where teachers are supplementing things. So they are finding programs, computer games, games in general to supplement. So we're zeroing in on your program. So before we get into strategies on fluency, you have to first look at what is happening in your program. So some programs like Eureka Math, I don't know if Eureka Math is a popular program in Kentucky, but they have things called sprints. So their sprints are designed to try to address fluency. Other programs have different. Some programs have nothing. Just sort of depends on their approach, but we're trying to sort of supplement that idea of fluency practice from a core program perspective. The next thing that we have to talk about, and this is going to drive how we do these things, which are learner characteristics. So we have a lot of labels for students. Labels serve a purpose more on the line of advocacy for funding and resources, but labels do very little as far as telling teachers what students' instructional needs are. So, you know, a kid with a learning disability could have huge differences, two kids differences. But what we want to look at are what are called learning characteristics. In other words, that kid sitting in front of you, forget the label. What are their characteristics of learning? In other words, how are they approaching learning? And there are two kinds of learners really sitting in our classroom. We have strategic learners and then we have non-strategic learners. Now, I won't read through this screen on the bullets, but a strategic learner is that learner that's sitting there that's ready to learn. They're organized, they are monitoring their learning. So that's a biggie. So they monitor their learning, which allows them to self-identify where they're having problems. And then they do something about that. So the best indicator of a strategic learner is the learner that raises their hand in the middle of class, says, wait a second, I don't understand what you just said. I'm confused. So that's the first cue. They know they're having a problem. Then you say, so what is it that you don't understand? And here's your second cue that they're a strategic learner. They're able to tell you what they don't understand. That's key. Where the non-strategic learner, when they're confused, they don't ask you a question. You can just see it on their face. Then you say, Mark, you look confused. Can you tell me what's wrong? And they look at you and they like, I don't know. I don't understand anything. Who are you? Are we in math class? Right? They're just not regulating their learning. So that has some implications for a lot of things. Now, don't think all your students with learning disabilities are non-strategic. There's a lot of kids that have learning disabilities that are actually very strategic. Some of your gifted kids are actually not strategic. Sometimes you don't understand how they get it, but they eventually get it. So it's not a label thing, it's a characteristic. But when we dig into these characteristics, they're going to impact math at various levels. These non-strategic learners, a lot of these characteristics impact a lot of things in math. Like when you're unorganized and you are impulsive, then problem solving becomes difficult. If you can't break down problems, they get overwhelmed and then they want to stop. A lot of this as they get older leads to they don't even try. But for our particular session today, what is very, very critical to us is this idea of memory. So this is where we're going to begin the conversation about cognitive processing and the importance of fluency to learning, is that these kids have difficulties in memory. So now we're going to kind of dig into this cognitive process. So this is really, really important to have a better understanding of what we're going to talk about later. So memory, or the cognitive process, is kind of made up of three pieces, two major ones: working memory and long-term memory. So the first piece is a sensory registry. This is how information is inputted or is taken in. So if you think about your senses, so you have visually, auditory, touching, tasting, smelling. I don't think there's a lot of tasting and smelling happening in math class, maybe science, but not in math class. But there's definitely visual, auditory, and then if you're using manipulative, obviously you're touching and moving. And they're kind of all interacting at one time. So that's how information is inputted in. Now I'm talking learning in general, not just fluency. So once the information is taken in, it gets dumped into working memory. So working memory is where that information is being processed, manipulated, organized. That's kind of the oven in the kitchen of learning. That's where the cookies are being made. Once they're made, then they move into long-term memory. So it's this piece here. So learning is kind of going this way. Now, a lot of times learning is going like this. So new information, they pull out something they learned previously, they anchor it, and then they move it. So this working short-term memory is interacting. So, well, what does this have to do with fluency? Well, this is actually the main reason why fluency was refocused in the Common Core standards, and has some derivative of that has shown up in all the states, as the states kind of took that core and then adopted them into their state. this is kind of the reason. So working memory here has a limit on it. In other words, you can only handle so much information in your working memory. Then working memory gets bogged down. And once working memory gets full, learning stops. Everybody following me on this? So this is really important. Working memory has a limited capacity. Once it gets full, learning stops. And once it stops, once it gets overloaded, it's done. So as it starts to fill up, information gets thrown out of it to make room for more information. So what fluency is the cognitive rationale is, as you become more fluent with whatever it is, you think less about it. So that translates to working memory, is that you're using less working memory. So if you think about little kids when they first try to start writing with their pencil, they got to focus on picking up their pencil and holding it. So writing is really slow. Think about when they first write their name. It's slow, it's messy, it's not crooked, it's not straight, it's all over the place. But soon they get better at writing with their pencil, and they start writing their name faster. It starts getting neater. They're not thinking about it. It's fluency. Think about when you first learn to drive a car. You got in your car and you're going through a mental checklist. Okay, seatbelt, mirrors, handle. It's cognitively slow. So the idea with fluency is we want to free up that working memory so it can focus on problem solving, reasoning, explaining. And we don't want kids getting bogged down on their facts. So the real rationale for fluency is not really math per se. It is capacity of the working memory. If we free it up, then they have more capacity to learn, to process, and to move forward. So this is going to be a driving theme throughout, is that the reason we want kids to become fluent is to offload. So there's a key word. Fluency offloads working memory. It frees up that capacity to do other things. What we are trying to avoid is overload. So when kids are constantly having to reach for a calculator, constantly having to do strategies, sing songs, tap out the facts, that is not bad per se for math, but eventually that's going to bog down their working memory. And then when you ask them to explain something, they're going to have no idea how to explain it because they've been worried about the fact. So that's the idea here, is that we are trying to offload working memory so that they can better think. Now, the limits in working memory are also going to impact how we practice. So we are making some cognitive mistakes inadvertently when we set up practice for kids, and we're overloading their working memory in practice, which is then creating this barrier to developing fluency. So this is going to be a driving force in our session today and tomorrow. You're going to hear me talk about working memory, overload, why we're doing the things we're doing later on. So this is a biggie. Now, I also think it's very important whenever I'm talking about fluency to highlight the fact that becoming fluent in anything doesn't mean you're good at it. Other things. So in math, we have to do conceptual understanding, computational fluency, factual knowledge, and all of those is what make people good in math, not one. So I don't want anyone to be under the illusion, especially if you're a special ed teacher, if you just get the kids to memorize their math facts, they're going to be good problem solvers. That's not how it works. But becoming fluent on your math facts is going to allow better processing to do other things. So we have known for decades that kids that struggle in math have issues in their working memory. So the new phrase for this is executive functioning. So I'm sure you've been in a meeting with a parent where they have the word executive functioning comes up, or processing. essentially, we're talking about working memory. So one of the ways that we help kids with working memory issues is to help them become fluent or automatic. Now, in a few minutes, we're going to do a bit of a breakout activity because I'm starting to throw around a lot of terms. So you're hearing fluency from me, you're hearing automaticity, you're hearing memorization. So you're hearing a whole bunch of terms. And this is part of the issue in math with this fluency is there's all these terms. People have different understandings of these terms and nobody's speaking the same language. But one of the ways to help kids with working memory issues is to free it up by getting them fluent on things. Now, obviously, basic facts is one of those, but there's a whole lot of other things as well once you get older. In middle school, we want kids integers. Calculus, we want kids, and trig, we want kids to know their trig function. So there's a lot of things that fall in here, but this is what we're kind of doing. Again, the idea is that we're trying to offload working memory. So now I'm going to unshare my screen here just for a second. If I can find, where is it? Oh, there it is. All right. So now, all right, I see some chats in there. So what we're going to do now is we're going to dig into working memory a little bit more. I'm going to do a little pseudo working memory test for everybody in here. And I know Mark has done this with me in the past and a few other folks that are in here as well. So you need something to write with on a piece of scratch paper, or if you want to type on something, that's fine too, but don't type it in the chat. What I'm going to do is say a series of numbers. When I'm done saying the numbers, I want you to write them down in the order that I said them. Has everybody got that? So no one's writing until I say write. So are we ready for this? Is your working memory ready? I know it's summer, so you got a lot of excuses here why this is going to be maybe a difficult task. But here we go. Pencils down. Nobody's writing. Here's your first set of numbers. 38, 17, 82. Go ahead. All right. Did thumbs up if you got 38, 17, 82 in that order. Thumbs up. Now, if you didn't get those, just give me a thumbs up. I don't even want to know if you didn't get those three. I know it's early on a Wednesday, but just play along. So, all right, we got lots of thumbs up there. Good. That's what I like to see. All right. Pencils down. Oh, where'd you go? All right, here's the next set of numbers. 30, 11, 83, 3, 27. Go ahead. All right. Check yourselves. Here we go. 30, 11, 83, 3, 27. Now, there's a few of you with your screen on. I can tell that you didn't get it right. Now, if you did not get that right, give me a thumbs up. Did not get all of those. I want to see how many were there. See how honest you are. The honor system. All right, I'm getting a lot of thumbs up, which is about right. I'd say probably at a quarter of you. All right, so if you did not get all 5 of those, I overloaded your working memory and you started to kick them out and you couldn't recall them. All right, okay, let's do the last one here. Now, this is really focus on this one. Breathe, take some peppermint candy. If you're on a bicycle chair, start riding that bicycle. It's not going to help you, but it might make you feel better, but it's not going to help you. All right, it's a myth that any of that actually helps with working memory. So here we go. 35, 10, 88, 9, 22, 64, 90. Go ahead. I can just tell by the few people that have their cameras on that didn't go that well. Jody, is your hand up for a question? If it's up for a question, I'll come to you. I'll come back to you in just a sec. Now, so Evelyn said I can only remember the first number. So let me read the numbers to see if anybody got them right. And I want you to circle any number you wrote that I didn't say. All right. So here are the numbers that I said: 35, 10, 88, 9, 22, 64, 90. Give me a thumbs up if you got all of those correct in the order that I said them. Okay, not seeing. Oh, I see one thumbs up. Two, no, one. So it looks like out of all of you, maybe 2 of you got them all right. Now, how many of you circled a number? In other words, you wrote down a number I didn't even say. Anyone? A lot of thumbs up there. So, okay, so now Nancy's saying I had 2 of these. So that's the other thing. Working memory isn't like a cumulative thing. Like you remember 3, then the next time you still remember 3, and then the next time after that you remember 3. Once working memory gets overloaded, you don't remember anything. And you start writing stuff down I didn't even say. So this is really the foundational rationale for fluency, is the more that we can get out of that working memory, the more they have free to do other things. Now, there is a pattern. So Sarah saw a pattern. There's definitely a pattern. I'll show the numbers in a second, but I just want everybody to kind of just process what I just did for a second. In context with what we just learned, kids that struggle in math have limits in their working memory, greater limits than others. We all have limits, and that limit is around 5 pieces of information plus or minus 2 or 3. We've known that forever. So math is a whole lot of information that has to be processed at one time, and we start to overload it. So that is the rationale, is that the more fluent to automatic you come in certain things in math, it lowers your working memory load, and it's free for reasoning, problem solving, the whole 9 yards. Now, I want to kind of just pause for a second and open it to any questions. So some of you said, I remember the first and maybe the last. So that's very common. That's called the primacy recency effect. You remember the first thing you hear and the last thing you hear, and you miss everything in between. So how does that sort of manifest itself with our kiddos in class? They can get a problem started, then they're stuck in the middle. We kind of help them through the middle, then, oh yeah, and then they can finish it. So it's real common, primacy recency, to remember the first and the last. But does anybody have any questions or comments on that piece here? So Shannon's question is, if the normal's, I'd say the normal is more 7 plus or minus 2. So the person that remembered all of them, it's probably not because they have a larger working memory, it's that they organize it better. So the way that you help kids with information is you organize it, right? So ADHD, this is classic with ADHD, is there's no, you can't increase working memory per se. We went through that in the 70s. It doesn't work. What we do is we organize pieces. We organize things. So think about phone numbers. Here's your great real world example. Phone numbers, although no one has to remember phone numbers now because of our phones, but there are 10 digits in a phone number if you count an area code, and we remember our phone numbers. Well, how are they always presented? Chunks of 3 or 4? Social Security number is 9, but how is it presented? In chunks. Everybody, how many of us were annoyed when passwords had to be like 8 characters, a capital, a symbol? Well, we stopped using our birthdays or our kids' names. Now we use our kid's name and we add an exclamation point to it, or we say Tyler 1 2 3. So we try to organize things. So this is just something that we have to. There's no fixing working memory. We went through that in the 80s about processing, following dots on screens, remembering this. Your working memory has a capacity. The way that we help kids with that is that we organize content. So that's more of an instructional piece. Well, we're really zeroing in on fluency. So the way we're going to help with working memory is to get them to be more automatic on certain things in math. All right, now let me share my screen here. Okay, is everybody got my screen back up with some numbers, the first set of numbers? Okay, so again, if we go back here, everybody had no problem with these. It didn't overload. But when I got to 5, that's where I started to lose some of you. Then when I hit 7, I lost everybody, almost everybody. Now here's your pattern: is I organized them by their numbers. So there was 30s, teens, 80s, single, 20s, and then 60 and 40. So if you organize, maybe that helped. But by the vast majority with random things, once you hit 7, it's your working memory is just basically like what you're seeing on the screen. It just gets all discombobulated. So one of the things that's important in math is there's very few things in math that are less than 3 pieces of information. If I pick a 4th grade standard of long division, there's like 15 or 20 things happening there. So teachers tend to see steps and count them, but there's the reasoning behind the scenes. So we have to really pay attention to this when we teach things, but also we can help kids with this by getting them fluent. This is the rationale that most folks are not seeing or have connected to fluency. Fluency isn't about math per se, it's about cognition and it's about learning. So the whole rationale, why do I have to do fluency? Why do I have to have kids know their facts? It's not because it's in the standards, it's because cognitively, this is going to help kids better approach learning. We learn this in reading. Fluency in reading is correlated very strongly with comprehension, but just because you read fluently doesn't mean you comprehend. You have to learn other things. So just because you are fluent with your math facts doesn't mean you're a great problem solver. You have to teach that. But the fluency is one big barrier to students progressing in math. So here kind of a graph that's putting some things together here. So offload. So when kids are fluent, they're offloading. When you offload working memory, it's going to better let them access content of all sorts of things. Now, because we have limits in our working memory, that's going to be important to how we practice facts. This is the key piece. It's not just about learning, but it's how we set up practice activities that are based on cognitive principles. So kind of what we just talked about, like, why are we learning facts here? Well, facts are important for use of calculators. So back in the 80s, we said kids don't know their facts, they just use calculators. Well, what we found out is, guess who uses a calculators most efficiently? Kids that know their facts. My daughter, who's a non-strategic learner, she has a learning disability in math fluency. I saw her reaching for calculators when it was 8 + 1. So cognitively, she was saying, I can't do it. She reaches for the calculator. That's using upper working memory away from the problem solving. So we've got issues here. Calculator use is really kind of important, and it's actually how you use it is related to mental math. Estimation. As a math teacher, how many times in a math class do you say, does that make sense? Does your answer make sense? Well, the reason it makes sense is they've done mental calculation. Then this is from third grade on, this is where the middle school teachers, well, third, fourth, fifth, and into middle school, this is our nightmare that we're living. When you're slow with your facts, then it takes forever to learn math problems. When you don't know your multiplication facts, fractions become a nightmare. And then if you don't know fractions or you have issues with fractions, then algebra becomes an issue. So this is sort of this trend that we see with really struggling kids in math is one element, not all, but one element of their struggles can be directly tracked back to fluency. But I don't want anyone walking away from here thinking the way you solve math problems is solely by fluency. It's one element. Now, so far, I think, let's see if I've used all, well, I haven't used all of these. I've used fluency. You've heard me say automaticity or automatic, and memory. So accuracy is another piece, getting the fact correct. Flexibility, I haven't really used that one yet, and efficiently. So these are like all the terms that you start hearing when people start talking about fluency. So this is where I want to put everybody into breakout groups, Mark. So I don't know, how many people do we have on this session right now? So we got 71 counting. So I don't know if you want to put people into groups of 4 kind of randomly. And what I would like them to do is kind of discuss what I just talked about with working memory. And then, like, is fluency the same as automaticity? What is flexibility? How does efficiency? What is accuracy? And just sort of, what are you hearing in relationship to fluency in context of kind of what we're talking about today? And we'll give about 10 minutes in the breakout room. Okay, I think that's, all right, good. So I got into a couple of rooms, and the conversations in those rooms were kind of mirroring where I see the biggest, I don't want to say necessarily confusion, but the biggest sort of tension is this idea of fluency and automaticity and how they interact piece. And one of the rooms started talking about, they said, well, that's the last, or they said automaticity is without really thinking. And those are all the right kind of general terms. I want to start bringing this, parse it out, make it a little more cognitive. So there is a distinction between fluency and automaticity in math for sure, but as well as other areas. But here's kind of the best way for me to give an example of automaticity versus fluency and talk about this working memory piece. So I'm going to ask you a math fact here, and I do not want you to answer it. Don't answer it to yourself. Don't answer it out loud. Just do not answer what I'm about to ask. Everybody got that? So blank it out. Don't answer. Are we ready? All right. 5 times 4. Now, I said don't answer it, but how many of you had 20 pop into your head? Like everybody, right? So why? Like, why? Nobody sang a song. Nobody licked their fingers. Nobody drew tally marks. Nobody hit their head. Why did 20 pop into your head when I told you not to? All right. This is really a great analogy. So when I said don't answer the question, all of you started in your head saying, okay, don't answer it. Don't answer it. You were using your working memory, trying not to answer it. But you answered it anyway because the answer did not come from your working memory. It came from your long-term memory and just popped in. So your working memory was totally free. Now that's automaticity. And in one of the groups, that's the last stage. That's the last stage we want, is automaticity. Or I should say, some are arguing for that. Now, here is the example of fluency, where fluency and automaticity are different. Now, I want you to answer this as quickly as you can, all right? What is 157 times 29? Stephanie, what's the answer? Stacy, Shannon, what's the answer? You can't answer it immediately, but if you wrote it down, you could solve it fluently. There's the difference. Automaticity is answering without thought, which means you're not using any working memory. Fluency is you're going to answer that question accurately with some level of ease or efficiency, but not automatically. Does everybody see the difference? So this is really, really important here. Not everything has to be automatic in math, but there's a whole lot of things that we want fluent in math, but not automatic. So fluency is answering something accurately with some level of speed or ease or efficiency, where automaticity is answering without thought. And in math, there's content that we want for both. With the math facts, there is a progression that has to occur before we get to automaticity. We rush to automaticity sometimes, and that's not good either. So then kids know the answer, but they don't understand it. That's where I see that most often with your more stronger kids. So a first grade teacher says, I've got a student that has all their addition and subtraction facts memorized. I'm going to just have them do their multiplication. And the problem with that is they've skipped and went to memorization. So we're going to talk about the progression here in a second, but fluency and automaticity are subtly different, but they both have two elements into it: accuracy and then some level of speed.
Paul, there's a question in the chat box. Could you say that one more time about the automaticity and the fluency? The automaticity, answering without thought and so on. Can you just make that distinction one more time?
Yeah. So automaticity is answering without thought. You're automatic. Like that example, the answer came to you without thinking about it. So cognitively, you didn't use any of your working memory capacity to answer that fact. It came from a different part of your brain. So if you're solving a math problem and 4 times 5 is in it, you know it, you don't use your working memory, you can reason more, explain, etc. Fluency is answering accurately with some level of speed. All right, so that's this efficiency piece. So they can do it quickly, so it's not taking them an hour. All right, so like 5 times 4, a kid could go 5, 10, 15, 20. So there's accurate, but it took them a little bit of time. If that's a 3rd grader or a 2nd grader, oh, that's pretty good. If that's a 7th grader, that's a problem. Fluency is accuracy and speed combination. So this is where the tension comes into play, is sort of the progression, and that's what we're gonna talk about more. And Sarah, are you good with that? So the question in there about fluency sprints, it depends, Dana. It depends on how you're using them. If you're testing them and you're giving them some kind of score, then it's a test. Now, is it measuring fluency or automaticity? It depends on how much time you're giving the kids. I would tend to argue that those sprints are more accuracy-based versus automaticity, but we're going to talk about that. Hold your thought. We're going to get to that. All right, let me share my screen. Good question, Dana. All right, so understand that there are some subtle differences between fluency and automaticity. Efficiently and flexibly kind of is embedded within them. Memory is probably closest to automaticity. Accuracy is with all of them. All right, you're not automatic if you're not accurate. You're not fluent if you're not accurate. So the definition, kind of the formal accepted definition, is Math fact fluency is ability to accurately and quickly recall a basic fact. And that's kind of what we talked about. Now, we didn't really talk about, well, what does quickly mean? This is where there's some discrepancy. But in general, what we're looking at, and I'm going to revisit this later, is fluency is usually under 2 seconds. So 5 times 4, if I go 5, 10, 15, 20, that's over 2 seconds. So I'm not fluent, I'm accurate. I have a strategy, but I'm not fluent. The more I practice it, the more I'll get that efficiency piece in there. Now I want to, before we go too far, and I want to kind of get into the Kentucky academic standards and just sort of talk about it. The word fluency appears 25 times in the standards for Kentucky. So it is there. The term memorization is in there, automaticity is in there, but fluency is kind of dominating. But when I read through the standards, yes, I did that. I don't want to say misusing, the term is being used in a variety of ways, kind of what we just talked about. In some cases, they're talking about automaticity. In other cases, they're talking about accuracy. And in some cases, they're referencing flexibility. So it gets used in different contexts with kind of different meanings, but it's not parsed out. But again, this idea of conceptual understanding, building from procedural skill, fluency, and cognitive demand. So what we're starting to see is this idea of a progression. And that's what I really want to bring into now. Within the standards in Kentucky, they use efficiently, they use accuracy, they use flexibility, and they use appropriateness. They also use automaticity. They've never really defined, they define fluency, but not really automaticity. But what we're starting to see in Kentucky standards, like in all the standards, is that there's a progression that is occurring. And that is it. Fluency is best viewed as a progression. And this progression has very distinct stages that are grade level dependent. So especially in K to 3. Now, once you get in 4, 5, and 6, it's a little different because the stages should have already been made by the kid. So then you got to look at where the kid is. But that's what I kind of want to talk a little bit now. Now, what time is it? It's 10 o'clock. All right, we're going to go till 10:15, then we'll take a break. But I want to get into the stages of fluency. So like in general, there's a lot of misunderstandings about fluency, automaticity, what it means, how to do it, when to do it. Kentucky clearly has fluency built in. They clearly have a progression, and they also, like everywhere else, have a wide use of the word fluency. So we're going to look at fluency now in terms of a progression. So this is really important, depending upon your grade level and what grade level you teach. But there's 4 stages. The first stage is called understanding. So this is where the primary goal is that the kids understand the operation. So they understand what is happening with addition. They understand what is happening with subtraction, multiplication, and division. And this is usually done through a lot of manipulative use. So this is where in kindergarten, you're going to have 5 frames, 10 frames. You're going to see number lines. You're going to see tallies. You're going to see visual representations. In 2nd grade, you're going to start to see groups of. All right. The whole goal of understanding is that they just see what is happening. Accuracy, getting the right answer isn't important. Speed is definitely not important. Strategies aren't even important. In kindergarten, the understanding is primarily dependent upon counting. Now, how do you know a kid understands? This is sort of the bigger issue. So basically, there's 2 ways that this is where if kids can write a basic fact from a model. So you give kids some chips and say, write a fact, and they can do that. There's understanding. Or vice versa, if they're given a model, or they give a model for facts. So those are the two ways. So essentially, if I say, okay, everybody see these little frogs? So these frogs could be chips, tallies, tens frame, whatever. Write me a number sentence for this picture. Go ahead, write it down. Make sure I did it right on there. Make sure I have enough frogs. So if you give this to a kid, and then the kid does 4 + 3 = 7, they are understanding the model. Make sense? Straightforward. That's happening in kindergarten, early on in kindergarten. Now, it's not starting with the fact, it's starting with just the 4. Here's 4 frogs. What number? 4. Count them. Like, that's the initial piece there. Now, I'm kind of going over this quickly. There's a whole lot of other things in there, like subitizing, cardinality, one-to-one correspondence, all of those things that are kind of the precursors to this. Or if I say, okay, 4 + 3 = 7, show me that on the tens frame. Go ahead, show me that on your tens frame. Everybody dot that in. There's different ways to do this. So what you're looking for is the kid that takes the number sentence and then puts it into a tens frame. Then when kids can do that, they are in a good place for the understanding stage. Your programs do a good job with this. Almost all programs do a really good job with this. The understanding stage leads into the relationship stage. Now, I also want you to understand, these aren't like distinct, there's a lot of overlap. These things are happening at the same time in elementary school. So the understanding stage, this is probably the most important stage. Sarah has a question about, is it expected they verbalize this or they just write and understand? I mean, ideally, you want them to understand it. So if they show you, that's one level. Obviously, if they can show you, then verbalize it, that's another level. So I would say yes to all of these. Now, if you have kids that are not verbal, remember, kindergarten kids are sort of really developing language there. So the answer to that is, in the best case scenario, yes. At a minimum, they need to at least show you. The relationship stage, I think, is probably the most important and gets the least attention. And what I mean by that is we tend to kind of move, sometimes we move too quickly through this. In the relationship stage, this is really the number sense building, in my opinion. This is where you're going to get efficiency and flexibility later on. This is where they're understanding the relationships within operations and across. So within, they begin to really see the connections of addition. They start to see what happens when you double a number, what happens when you decompose a number. Fact families are a big part of this. The commutative property, +1s, +0s, right? So when my daughter was in kindergarten, she learned that when you take 0 and add it to anything, you get the same number, right? That additive property of 0. So she came home and was like, Dad, what's 1 million +0? And I go, I don't know what. She's like, 1 million. So she was like so excited. I said, so then of course I said, so what does 1 million mean? And she's like, I don't know, but +0 is 1 million. So she didn't really have understanding, but she knew that relationship. This is really where efficiency and flexibility come into play, like pulling apart numbers, decomposing numbers, putting them together, different ways of writing. This is the big piece. So in this stage, think about your curriculum, but you're seeing this kind of scenario. Here's your fact family. This is really setting up this piece here, which is in word problems. Now, we don't really see fact families presented as part whole. We only see that in like a bar model when we get to word problems. But this is really laying the foundation for flexibility. And this occurs at all levels of math. So when you have the same thing with fractions, you have the same thing with integers. Every level of math has this relationship stage where really this is where kids are going to develop this number sense piece. But these are all like commutative property. All of this is kind of lumping into that. So if you sort of think back to your curriculum, think about anything that has a relationship element. So it's first within, but then they start going across. So how does addition and subtraction interact? They undo each other. How do you use subtraction to find the answer to an addition problem, or an addition problem to find the answer to a subtraction problem? Oh, commutative property works for addition, but not for subtraction. Why? So all of that is relationship. Same thing is happening with multiplication and division. How do multiplication and division interact? How do addition and multiplication interact? So all of this is this, every activity, lots of them are building this piece. We tend to rush a little bit through this to get to the next stage sometimes, which is called fluency. Now, fluency has, I should really do 3A and 3B for fluency. And this is where we rush. Relationships, we rush a little bit. We really rush fluency. I want to make sure I'm giving a lot of information here. I want to make sure everybody, where are we at? Okay. So fluency. There's really two components to fluency. And this showed up in the definition. Accuracy and speed. The first thing that has to happen is accuracy. We cannot have kids trying to do fast facts if they're not accurate. So the whole focus of the stage of fluency is the strategy development. So this is where you're teaching the kids all of the strategies that you want them to be able to use flexibly. Now you heard the word flexibly. This is really that part. So, you know, if you think about the strategies, early on, we start with a count up or count on, then we count back. Then we do like near neighbors, make a 5, make a 10. We use addition to help us with multiplication. We use all of those strategies that you're teaching kids that are built into your program, hopping on a number line, tally marks, repeated addition, partial products, partial quotients, all of the wonderful strategies that are embedded. In some cases, we do too many strategies, to be honest. We just are flooding them. But I really want to drive this point home. The main purpose of the first stage of fluency is that you give kids strategies that they can use that will get them the correct answer, no matter how long it takes them. And I just want to make sure, I wanted that to sink in for a second. Now, you know, I haven't done any research studies in Kentucky, but I've done a lot of research studies in various places in the United States where I go in and I test kids in grades 1st, 2nd, 3rd, and 4th. And I give them tests on facts. Now, I don't call it a test, I call it a check. I try to take the word test out of fluency and use the word check. What I'm finding is the vast majority of our students are accurate on their facts. It is not an accuracy issue. It is more of the efficiency or the speed issue, and the ones are slow. So I'll test a group of 4th graders, and one kid answers 10 facts, but they got all 10 right. So they are 100% accurate. They're just slow. Another 4th grader has answered 30 facts. They got 27 correct. They're 90% accurate, and they're also fairly quick. Our programs do a really good job getting kids and teachers getting kids to the first stage of fluency. that's where we fall down. We don't go to the next level. So fluency starts off with strategies to get kids the accurate answer. And we like to have them have a couple that they can use in various problem types. So you start to see these strategies in word problems. You start to see these strategies in complex computation, but they have various strategies. Now, at the same time, there's some facts that are already becoming automatic. So the first one are the zeros. Like I said with my daughter, they become automatic on zeros. They become automatic on plus ones, times ones. So they're already developing some automaticity. Doubles usually comes in fairly quickly, doubles plus one. But that's the fluency piece. Now this is a good time for me to stop here and kind of let this let this thing sink in.
Can you repeat what you just said? There was a question in the chat box to repeat what you said about that, the strategy development for accuracy and then speed.
Yes. Am I still sharing my screen?
Yes.
Where do I get? Can't find where. Oh, there we go. I want to unshare my screen. All right. So, repeat about fluency. What am I repeating? Lena, can you give me a little more detail? Maybe unmute.
I actually think that you went back and restated it. You said the main purpose of the first stage of fluency is to give kids strategies to find accurate answers.
Yeah. So that is the main focus. So you don't want to rush speed. Now, what happens? Go back to my 5 times 4 example. I did it slowly. I got the right answer. Did I have a strategy? Yeah, I counted up. I did count multiple, skip counting by 5s. The more I do that, the quicker I'll get with it. 5 times 4, 5 times 5. I'll start to get a little faster. But if I keep counting, I'm only going to get so quick. And that's where the next stage comes into play. So we do a good job up to this. We do a good job getting kids fairly efficient with strategies. It's the last stage of automaticity, which I'll talk about after we have our break, where I see the biggest gap. And I want to get your kind of thought on this. So we'll take a 15-minute break here. On this break, obviously get coffee, use the restroom, get some fresh air. But I really want you to think about your kids. The kids that you have this past year, was it a strategy issue? Was it an accuracy issue, or was it a speed issue? Now, my research was done before the pandemic. Pandemic has influenced this fluency piece because we didn't do it as much as we'd done previously. But really think about the kids you just had, especially if you're in grades 2, 3, 4, or 5. And then if you're in middle school, is it a fluency issue? Is it an accuracy issue, a strategy issue, or is it that efficiency speed issue? And we will take our break now. Mark, do you have anything you want to say? What time is it? All right, so welcome back. So we've gotten to stage 3. Now, as you're thinking about your kids that you had last year, for the end of last year, this is really the critical question is it an accuracy issue, or is it a sort of a efficiency speed issue? In other words, are your kids accurate and slow, or are they not accurate? And even when I do research with students with disabilities, they tend to be fairly accurate, have multiple strategies. They're just really, really slow. I don't know if anyone wants to say anything or make a comment or put it in the window. There are obviously kids that are going to be stuck at certain stages, and it depends on your grade level for sure. But we tend to have everybody kind of doing the same thing. And when we go from the fluency stage to the automaticity stage, or the fluency to where you're trying to get faster, this is where it's really important to make that distinction. If a kid is not accurate, so in other words, you give them some problems and they're giving you the wrong answer, and they're using a strategy, you've got to then ask yourself, are they using the strategy incorrectly? Or is there a broader misunderstanding that you're going to have to go back to relationships or to understanding stage? So, there's obviously kids at all the different levels, but I'm trying to get people to look sort of broadly. And what I'm tending to see is we do a decent job at getting kids to this stage. And hit and miss. But the reason I'm bringing this up is if you have a kid that is not accurate, you do not want to go to the automaticity stage until they become accurate. And that is a key piece here. So my daughter is very accurate now. She's not as automatic as, a student should be, but she has a learning disability that manifests itself in the processing area. So she's going to be slower. But if you have kids that are not accurate, then you do not want to go to the next stage. Now, the strategies we're going to talk about are going to the next stage. If you have kids that aren't accurate, you just got to go back a little bit. Now, when you go back a little bit, you've got to go back in a strategic way. Like, don't teach them a bunch of different things and say, pick it. Start to narrow it down to here's how you solve this kind of problem. We're going to practice it. Here's how you do this. If it's an understanding stage, you don't want to go back to really tallies if they're up in the grades 3 and 4 and 5, unless they have a significant disability, because then they're going to be counting. All right. Now, if you have a kindergartner or first grade, second grader, you may have to go back to subitizing. Subitizing is a whole nother element, but subitizing is the ability to recognize the quantity of sets without counting every single set. That's a big underlying precursor to facts in kindergarten and first grade. So, for example, if you could put 5 chips on a 5s frame and they're in order, or in a 10s frame and they're in order across the top 5, kindergarten kids should be able to just look at that and go 5 versus going 1, 2, 3. So they have one-to-one correspondence, but they're not subitizing yet. If you take those 5 chips and you arrange it in a 10s frame where there's 3 on this side and 2 on this side, we want the kids to go 3, 4, 5. They're saying subitizing there, or maybe even 5. So in the early levels, that understanding and relationship stage is definitely something that you're really living in. But once you get into the middle of first grade and then into second and third for addition and subtraction, you're really more in stage 3. The fluency piece, where you give them strategies and you want them to be efficient. Now, middle school teachers, I know that one of the primary issues raised with teachers is that they don't know facts. And again, I just want to parse it out. We have to be very careful when we say we don't know facts. Research, the data is showing they get the answer. It's just they're doing it so slowly. So those are things you want to dig into. And I would try not to use the word they don't know their facts as the phrase. You need to use they're not accurate, or they are slow. Those are what we have to start using to describe kids. So, and COVID has certainly impacted this. That one of the big things that I'm seeing in math at the younger levels is the strategy use was impacted by COVID. Teachers didn't get to see the kids didn't get to see it. So you just have to really begin to look at these stages and see where the kids are. Your program has tons of good activities in them for stage 1, 2, and 3. Where they sort of fall out is stage 4, which is what we're going to talk about now. But does anyone have any other questions or comments up to stage 1, 2, and 3? All right, we back on my PowerPoint? All right, good. All right, so the next stage, and this is where we're going to really begin to focus, is automaticity. Notice it's the last stage. And it needs to be the last stage. We do not want to rush to this stage. Where I generally see the rush occurring is when a teacher says, oh, I got a second grader who knows everything, addition and subtraction. And then they start doing multiplication speed and they skip all these 3. So we do not ever want to skip to automaticity. It just doesn't do anyone any good that you have memorized something. So I go to take my kindergarten daughter who has a learning disability and started having her memorize her multiplication facts, and it would not have benefited her in any way. So we're not skipping steps. So as you look at kids, the step you're going to be focusing on is really going to be grade level dependent in terms of where you're at with your kids. So at the automaticity piece stage, a couple of things. I used a lot of does not in here after not very positive slide, I should say. But fluency does not guarantee automaticity. And that is probably the single biggest mistake we made, is we thought if we got kids accurate and gave them lots of strategies, they would automatically become automatic. And that's just not the case. And it's not the case in anything in life. Automaticity comes from some focused, purposeful practice. And I'm just going to throw this out. Drill and kill is not. That is not purposeful or planned. All right. So a lot of teachers say, well, I learned it. Well, okay. We did a lot of things that we don't do anymore. It would work. It's just for kids that struggle, that's going to be very negative experience. Like my daughter, that's going to be a problem. For my son, who was a strategic learner and very good in math, then he would survive those things. My daughter, that was very detrimental to. And some of these things we've talked about, automaticity without understanding, without relationships, and without strategies does not develop mathematical proficiency. So rushing to automaticity does not benefit anyone. Automaticity in and by itself does not mean we're going to be good problem solvers. So again, back to one of my early statements, just because they are automatic with facts doesn't mean they can then problem solve. And that's something that we just, it's a small part of math. But the key here, automaticity allows more cognitive capacity to be available, or diverted is another way of looking at it, to problem solving, reasoning, and explaining, which does promote critical thinking. So that's kind of this is sort of my summary of what we talked about. And I know I've spent some time on this, but I think it is important that we view fluency through those stages so that we can match our instructional activities to where our students are. So this is where most programs have dropped off. And in part, this is also where I should have said this. This is where people fall into different camps. NCTM is not necessarily a big proponent of automaticity. They're very much, let's just get kids to fluency and flexibility, and then we're good. The cognitive folks who study the brain and how the brain works, they're really saying, well, that's not good enough. We need to get kids so that they're automatic, so that it frees up resources. So these are conversations that you want to sort of start having back at your school, at your grade level, or even at the district level, is, well, what is our position? What is it that we're going to do? The standard should be viewed as minimum. We can always go beyond those, but are we going to address automaticity? This is a decision you have to make. But if you do decide to do this, then there are certain things that have to be in place in order to do it efficiently and effectively. And that's what we're gonna get into. But I want to do just another kind of breakout activity. Since I had you thinking about your students, and there were some comments in there about like they can't count on, they don't understand, COVID has really impacted this. What I really want you to now begin to think about is, if you're a first grade teacher, end of first grade, how are your kids on addition fluency? What stages are they at? Second grade, addition and subtraction. Third grade, addition and multiplication. Fourth and fifth grade, sixth and eighth, you just focus on multiplication. Somewhere in this grade level, the priority becomes multiplication, because grades 4, 5, and 6 is so heavily focused on fractions and ratio and proportions that multiplication is the priority. But Mark, if we can put everybody back in the groups again, and I know there'll be different grade levels mixed in, but sort of ask yourself, how many kids, what percentage of my class was having issues with the facts. And then, is it a strategy issue? Is it an automaticity issue? Is it a relationship, or is it a understanding? And COVID has certainly thrown more kids back into stage 1 and 2 because of what had happened. But anyway, we'll just have, I don't know, about a 5 or 6 minute discussion, and sort of like, how big of a problem is it, is what I really wanting you to kind of discuss here. All right, so as we're moving forward, again, those 4 stages, like, really, like, anytime you're looking at it, certainly if you're an interventionist or a special ed teacher, really look at those 4 stages. But obviously, if you're an elementary teacher, the grade level you're in is going to dictate the stages. In kindergarten, you're pretty much in understanding relationship stage, some strategies, but the strategies are more the counting piece. But as you get into 2nd, 3rd, and 4th grade, you're really moving into stage 3, 4. So really kind of pay attention to that. Now, there's a couple of questions in the chat box I just want to talk. The first one is this idea, like, are there programs or activities to help kids develop their working memory? No, there is not. A working memory is kind of a fixed piece, but there are things to help kids organize their working memory. All right, so that it's more about like organizing to use it as efficiently as possible. There is we went through this in the 70s and 80s with like all these biofeedback machines hooking people to electrodes. My dad was a school psychologist, so I got to do those things behind a double one-way mirror for my dad's class. I never realized those mirrors were two-way or one-way mirrors until I was in college myself in one of those labs. But there are not programs that increase working memory. Now, the other questions about reflex and extra math. Now, I'm not endorsing programs, but reflex and extra math are designed for stage 4, automaticity. So if you're a 1st grade teacher, I would say you shouldn't be using reflex math really until at least January or February. Now, if you're a 4th grade teacher, yeah, those are a 3rd grade teacher or a 2nd grade teacher, but in 2nd grade, you'd be using reflex math with addition and subtraction, not multiplication, right? So again, the grade levels vary. Those 2 programs, you will see as we get into the elements that are important for fluency fit the bill. So those are all options. Now, they're both computer-based. One of the things that you're going to hear me say a little bit earlier is there seems to be a level of importance to verbalizing facts in practice. So actually, for the kids to actually say 4 times 3 equals 12, like saying that out loud for struggling kids is kind of important. But you'll see why I'm saying those programs should be options because of how they're designed. You got to look at the design. So I'm going to give you a blueprint so that when you say, hey, what about this? You will have kind of like 3 or 4 things to look at. Does it address this? Okay, then this is something we might want to look at. So that's sort of how we're going to move forward with this. All right, so let me share my screen. So I guess in that conversation that you were having, how big of a problem it is. Now, in the groups I were in, we definitely noted there seems to be more of an issue with relationship stages than maybe previously, probably because of lack of manipulative use. And when the school kind of when everything went virtual in that March of 20, there were a lot of kids in 1st and 2nd grade that were in the middle of relationship stuff that missed it. So, but if your conversation was, well, all my kids are fluent, they know their math facts, there's no problem here, then that's great. You're probably not going to need to use what we're going to talk about with as many students. So this is about who needs it and then giving them the opportunities. So, all right, so back to our kind of definition again: accuracy and speed. Accuracy before the speed piece. Okay, so Mindy, I'm going to come back to that. That's a good question there. It's a really good question. So again, we're looking for about 2 seconds. So that means if you show a kid a fact, they should be able to give you the answer in under 2 seconds. Now understand, some facts, it'll be immediate. Others will push that 2 seconds, but that's kind of what we're looking for. So if you were to give kids fluency check, either showing them cards or facts on a paper, then what we're looking for is that they answer about 30 to 40 in a minute. So if you're looking for like, how do I know if my kids are fluent? Well, each fact under 2 seconds, or you kind of give them a group of facts and they can answer it in a minute. 30 to 40. Rule of thumb. And again, fluency is not really designed to be like graded or, this is a check, and where we're at and what we're looking for is growth. We slowly increase. All right. Now, if you have kids, in middle school and they're at 25, 26, I'm not too worried about that. But if you have a middle school kid who's like at 8, then that's going to be a problem for that student. So it's all about kind of the idea. Now, the question in the chat box was transferring from paper to pencil. So it's interesting you brought that up, because that is a concern that has been raised. Like kids practicing on Reflex, which is a computer game, and Extra Math, a computer game, or other games that are computerized. Does it transfer to paper and pencil? So I was getting a lot of information that it wasn't. So we actually did a study, and the study actually used Reflex Math. So the kids did their practice on Reflex Math, and we tested them with paper and pencil, and we actually found that it did translate to paper and pencil. So that was positive, but that doesn't mean it's going to do that for all students. So I think if you have all computer practice, you should sort of embed some paper and pencil in there as well to sort of bridge that gap. But in our particular study, we did find that it transferred to paper and pencil. But my bigger concern with the computer practice is there's no verbalization in that practice. It's all typing an answer. And I think the verbalization is what is important for a lot of kids that are struggling, especially kids with learning disabilities. All right. So 30 to 40. All right. So now, kind of summarizing our morning conversation for today is fluency, including automaticity, is needed for single facts, but it also goes beyond. When you get to middle school and high school, there's integers, square roots, perfect squares, other things. We're going to talk about that too. But the reason fluency is a focus is it maximizes working memory. That is the key, is we want to maximize that working. In other words, we don't want kids using all of their working memory on facts. We need to move them so they can use that on other things. But automaticity is a big problem for kids with disabilities, executive functioning, chronic low performers. Drill and kill, typical things are not going to work. We need purposeful, planned, and targeted practice. And that's kind of what we're going to move into now. Purposeful, plan, and target. So this is where I really want you thinking about the activities that you are currently doing or that have done. Maybe you have to think back to pre-COVID, but the activities that you do that you are saying this is for fluency. Now we're kind of bridging that fluency to automaticity gap. And we're going to get into the ingredients that have to be in those activities. Now, there's a lot of different ways you can do this. It can be games, it can be paper and pencil, it could be computer, it can be partner practice, it could be old school flashcards, it could be practice sheets. The nice thing is everything's on the table, but we have to look below that. We have to look at the design features in there. So those of you that said you used Eureka Math, we're going to do a deeper dive into the sprints. How are they designed? How are they using? And look at the design based on what we're going to talk about. So this is where I want to, we won't do this as another breakout activity, but in the chat box, we'll kind of do like a free for all here. What are the things that you're doing now that you say I'm doing for fluency? So we already know there's some computer programs, Reflex Math and Extra Math out there. But what are other things that you do for fluency? And if you just want to start throwing them in the chat box, I'll kind of read them out as we go. So sprints, that's embedded in the program. Reflex, Extra, Fly Swatter Facts, card games, math talks, rocket math. You're hitting all the ones. These are all, I run into every one of these. Number talks. So see, there's a lot of overlap. The bell ringers. Soup games, 99 Math Money Max, Math Wall. Jennifer Bay Williams, Math Facts, University of Louisville, flashcards, multiplication, buzz game. So everybody's kind of doing the same genre of things. We've got some flashcard stuff happening. We've got some computer practice happening. We've got games happening. Number talks. Number talks, in my opinion, isn't really a fluency activity. That's more of an understanding and a relationship activity. Moving into strategy, if they talk about how they solved it, but I would not call that an automaticity activity. They're good. That's a good activity. I just don't think it fits in with automaticity. All right, so good. All right, so everybody's doing things. So that's the nice thing about it, is that you're all doing stuff, which also is a problem, because I think most of you are telling me that fact fluency is a problem with your students. Would you agree? I guess if it wasn't, you probably wouldn't be in this session, right? So you're all telling me it's a problem, but yet you're all doing all kinds of things to address it. So that leaves the question open, is then what we're doing is not working. Now we need to think about what we're doing and maybe make some tweaks. Now, Cynthia, you said amen. Is that amen? Is that some kind of fact fluency practice game you're doing? Or is that amen to my comment that I just said about we're doing all these things, but it's still a problem?
It's still a problem.
Okay. So this is like a kind of this awkward situation. Like you're all doing things, but it's still a problem for a large number of kids. So that's telling us, we need to look at what we're doing and maybe make some tweaks or some adjustments to those. And that's kind of what we're gonna talk about here. So the nice thing is all of those things that you mentioned can be adjusted and used for what we're going to do. Again, it's about matching the activity with the stage. So in my opinion, number talks is not really automaticity building. It's either going to be understanding, relationships, or talking about strategies, so more accuracy. So this is one of the things that we have to really begin to look at is, are our activities helping the kids with accuracy, or are they helping them get faster? And based on the conversations I'm having with everybody in here and everywhere else, is it seems to be helping with certain elements of stage 1, 2, and beginning of 3, not on the automaticity piece. So, all right, good. So keeping those in mind, let's get into how close I was. So this is what I wrote down before I asked this question. And you can see here, that I pretty much said everything that you have. So games was on there. Nobody said mad minutes, but the sprints are pretty close to that. Flashcards, no one said singing songs. Did I miss the singing songs in there? Usually that comes up. Then commercial programs that I generally run into, look at this. Somebody said Extra Math, someone said Rocket Math, someone said Reflex Math. So I basically picked out what you have. How about I don't do anything, it's parents do it at home, because I run into that a little bit. Computer, give a calculator, I don't others. So we're all doing things. And my question is, are these activities purposeful, planned, and targeted? And, you know, these programs here, Extra Math, Rocket Math, and Reflex, that's a yes. Flashcards, it really depends on how the teacher's doing it. Games, this is what I want to kind of dig into, because games is the primary focus with fluency. And I just want to talk a little bit about games. So games can definitely be purposeful, planned, and targeted. I think they're more purposeful and planned, not as much targeted. Because we're going to talk about targeting in a whole nother different level, but a couple of things with games. First element of game is it's usually competition based. In other words, you're playing against another student, right? So competition can be good, but it can also be very bad. So my daughter, who is slow in her facts, games were not good because she was slow and she was always what? Losing. So competition, you have to be real careful. Competition is only good if the two people that are playing are of equal levels. If one is faster, one is not. Do you guys remember Round the World? The older teachers in here, do you ever remember playing Round the World? That's the most poorly designed game for fluency ever. I know people are laughing like, what? I love that game. I use that game. Who gets all the practice in Round the World? My daughter who's slow, or the kids that already know the facts? Kids that already know the facts. So we got to be careful with games. Now, my biggest concern with games is they are not targeted because they often have a random element built in. Spinning, rolling a dice determines the fact. Like on these board games, where you fall is the fact you answer. So it's random. So that is not targeting if they're random. We want to look at targeting at a much better level. I think games are great for the accuracy and the strategy development, but not for automaticity. So I think games are great in the beginning of stage 3. But they are not necessarily good for automaticity. In competition, you have to be very careful if it's two kids competing against each other and whoever answers it first is the winner. Those are the games that are going to be problematic for struggling kids. So games, I think, games tend to be more focused on accuracy. In other words, getting kids strategies to get the right answer, and not necessarily on automaticity. And if you have kids competing against each other, in other words, the game is whoever answers it first is the winner, so to speak, then that usually just helps the faster kids and not the kids that are struggling. So games, I think, have its place stage 2 and stage 3, but building automaticity, games are not, in my opinion, the most effective way to get kids to automaticity. And this is a big push right now. Jennifer Bay Williams, who I know and have worked with, is big on this game piece. And but I just think games are better suited at stage 3 versus the automaticity piece. And I love games, so I don't want anyone interpreting anything I'm saying is that games don't belong in fluency. They just more in stage 2 and 3, in my opinion, even stage 1 to some extent at the younger grade levels. But when we're trying to get kids automatic, then there's some certain things that have to happen that are more difficult to embed in games. But if you're rolling dice to practice math facts, essentially it's random practice. You don't know what facts are going to get. And that's where targeting is sort of thinking of a funnel. So as an interventionist, You don't have a lot of time with the kid's struggling. You need to funnel down and practice on exactly what that kid needs. You can't be wasting time on other things. So that's where we're going to talk about getting things more targeted in terms of practice. CCC would be targeted, yes. And are you looking ahead in the materials? Because that's one of the strategies we're going to do tomorrow. So no looking ahead. But again, actually, I would say not necessarily. It depends on how you set it up. So this is what we're going to talk about with this targeted piece. Now, when you're thinking about fluency, you read the article. Okay, good. Wow, you read the article in advance. Bonus points. It is one component. So I really want to make a very critical point here. When you have kids that you're saying they're accurate and they got strategies, now I want to help them become automatic. We are talking about 5-minute activities here, distributed across time. I would be mortified if I came in your room and he said, Dr. Riccomini, I'm doing 35 minutes of fact practice. No. 5 to 10 minutes is what we're looking for. In a general ed classroom, 5 minutes. In an intervention, maybe up to 10. But we're looking for focused activities that are distributed across time. However you're doing it is going to have some cognitively based practice elements. Purposeful, planned, and targeted. It's one element. So, these other baseballs, you got problem solving, you got conceptual, you got procedural, you got language, you got reasoning, you got estimation, you got making sense. We got one piece in here with fluency. So I just want to make it really clear that this is something that is a 5 to 10 minute activity distributed across time. And not 30 to 20 to 40 minutes. We don't want that. So today, what time is it? Okay, good. So today we're going to get into the basic elements that have to be involved in practice and this idea of incremental rehearsal. Now, I have incremental rehearsal as a separate strategy, which it is, but I really want you to see that the elements of incremental rehearsal can go through the other three. So it's not like these are all separate. There's a lot of overlap, but there are some underlying principles or ingredients. So I call it ingredients, and that's why we have cookies up here. It's cookie break time if you have a cookie. So we have a chocolate chip cookie and we have a sugar cookie. So the ingredients of strategies can break down into two pieces, non-negotiable and negotiable. So non-negotiable means it has to be in the strategy. If it's not in the strategy, it's not going to work. So chocolate chip cookies, if I make chocolate chip cookies, chocolate chips are a non-negotiable ingredient. In other words, if I don't put chocolate chips in it, I've made cookies, but I have not made chocolate chip cookies. Now, what are negotiable elements when I make a chocolate chip cookie? Maybe the type of sugar I use. Maybe if I put nuts in it or peanut butter chunks in it. Still chocolate chip cookies, but I've added some. So there are negotiable elements as well. So as you're looking at these strategies, I'll point out the things that are absolutely non-negotiable. Now, what are negotiable things like, well, writing, saying it out loud, using it on a computer? Those are negotiable. You can use those how you want. 10 minutes, 5 minutes. But non-negotiable are the key pieces. This is what will make the strategies work or not work. So here are negotiable things. Fact fluency practice can be written, it can be silent, it can be verbal self. Have you ever, like the PVC phones, any of you have the PVC phones for reading in your class? They can verbally self-practice themselves, practice with a partner, computer, games. They all have advantages and disadvantages. But how you do the practice is up to you. Now, I would recommend mixing it up. Now, some of you have computer programs. So Reflex is a paid program. It's not free. It's kind of pricey. Extra Math is free. So whatever the computer program is, what I really encourage teachers to do is put the kids on it for 6 weeks and monitor that very closely. Make sure they're doing it, essentially. And if after 6 weeks they're not making progress, computer practice will not work for that kid, and you got to switch it. So monitor and adjust 4 to 6 weeks of any of these games. If you don't see a lot more of their facts going from red to green and they're kind of not improving, then that's not going to work for them ever. So you need to switch to something else. But here are the 3 non-negotiable ingredients. So these things, if you're going to help kids get to automaticity, these things have to be in play. Opportunity to respond. So whatever it is, you need to make sure that they're getting multiple opportunities to respond. So games sometimes don't do that. Everybody gets a turn one-on-one. So not everybody's responding. So there may be 10 turns, but if there's 3 people in it, then each person only got 3 opportunities to respond. So everybody has to have multiple opportunities to respond. But here is the key piece. Each fact should be occurring multiple times in the practice session. So back to the old school flashcards, the way many of us practice that are older, I should say. There's probably some newer teachers in here. Where you go to any store, you buy your flashcards. Each fact is only on that pack one time. And the way we generally do it is the kid shows it. If they get it right, where does it go? It goes in the right pile. If they get it wrong, where does it go? In the wrong pile. They only get 1 opportunity. So in this situation, if 5 times 6 is a fact you're working on, then 5 times 6 is going to show up a minimum of 3 times in that one practice session. So we're getting multiple opportunities. All right. If I go to the University of Kentucky, now I know you got University of Kentucky and you got Louisville. I don't know which allegiance you are in this region. Obviously, I am a little annoyed at University of Kentucky because they took our quarterback Levis and now he's a superstar down there, right? He's still there, Mark, right? All right. But then you got University of Louisville, the Cardinals. But I'm pretty sure if I go to their practice, number one, the coach isn't like rolling dice and deciding what play to practice randomly. And they're not just doing it one time. They're doing it multiple times in one session, and it's very focused. That's what we want to do here. So this is the big changes. So when you look at your activities you're doing, are the kids getting a lot of opportunities to respond? All of the kids. And are they getting opportunities to respond on the same fact multiple times? That's the biggest mistake. Sprints, that's one of the weaknesses, is they're not necessarily repeated. Now, some of them are, but not a lot. Extra math and reflex math and rocket math all repeat facts in the same practice session. So look at what you're doing. Games, if it's random, you don't know. So that's the first thing, is multiple opportunities for every kid, and the facts are repeated multiple times in the same practice session. So if you do flashcards, that means you have to put the same fact on multiple flashcards, or stop with the piles. You just put them in order, and that way you keep redoing them. Next, and this is the other big change. In my opinion, 1 and 2 are the things that aren't happening unless you have a program that has it built in. 3, I think, happens. Second one is targeted. Now, this is where we really are digging in. Targeting means you, the teacher, control the number of unknown facts that you want the kid to focus on. Now, unknown means not fluent. So in other words, if I show them 4 times 3, they have to do some strategy. So instead of saying unknown, I should say not fluent. So you're gonna group that to 3 or 4. So flip to the reading for a second. in first grade, I think there's something like 75 sight words that kids have to learn by the end of the year, or 55. I forget exactly what it is. If there's a first grade teacher, they probably correct me. You're not practicing all 55 at the beginning of the school year. You pull out 3 or 4, you focus on those. Once they learn those, you add some more and you slowly build in. This is the key piece right here, is targeting your practice to a group of 3 to 4 facts. Now we'll see how many people were paying attention early on and how many are making this connection. Why did I say 3 to 4? Why am I not saying 5 to 6, 7 to 8, 9 to 10? Why am I saying 3 to 4? Oh, I like the chat. I like the chat. That's good. That's good feedback for me. Thank you. So working memory, that is exactly spot on. You're either really good students or I was able to communicate that really well as a teacher. We know 3 or 4 is a manageable chunk for almost everybody. Now, you may have a kid that needs a chunk to 2, but we know 3 or 4 is a manageable chunk for almost everybody. That's what we want to look at. So no, it can be less, but not more. And that's exactly right. That's the answer I wanted. What I did not want anyone to type in the chat was, well, you said that's meant. This isn't about Riccomini. This is about the cognitive research that we know about working memory. So the 1 and 2 are the most important things. So when you go back and look at your activities, say, am I doing 1? Am I doing 2? And if the answer is no, the next question is, can I adjust it to do these? In my opinion, it's hard to do this with games, especially if they're rolling dice or pulling cards. It's hard to do these too. Now, maybe with the dice, you put masking tape on the sides and you write the fact families on there. So you at least know they're practicing within the fact family, but it's still, you're not controlling it as much. Now, the next piece is feedback. So right away, the kids are seeing yes or no. So this is where the way you practice can impact things. So if you do written practice, usually the kids write all their facts and then they give it to you. They get feedback after. They're still getting feedback, but it's after the fact. If you do partner practice, then they can get feedback right away. 4 times 3 is 15. No, you missed that one. Try it again. So it happens right away. So the way you practice impacts the game. This is actually one advantage of computer practice, is they get the feedback right away. Now, there's some disadvantages of computer practice, but one advantage is the feedback is fairly quick. So whatever activity you're doing, so all those things that you were on there, there are names of games I never heard of, fly swatter facts, freckle math games. What you want to look at is, do they have these 3 things in place? If they don't, then they're not really going to be effective for the struggling kids and the kids with disabilities. They may be all right with the more strategic learners, but the non-strategic learners are probably not going to get where we want them to be. All right. Now, these are the key things. So let's look at, this is kind of the cycle we're looking for practice. And again, there's all different ways to do this, but basically the kid sees the facts presented, computer screen, iPad screen, paper, projector, flashcard, whatever. Then the kid answers, and what we're looking for is that they're answering it under 2 seconds. If they're going past 2 seconds and they get the right answer, then you're working on accuracy, not speed. So there's a timing element. The kid can either say it, write it, or typed it. Then they get feedback, then they make adjustments. So that's the cycle. So again, we want these 3 elements in place: multiple opportunities, targeted practice, immediate feedback. We're kind of looking for this cycle. So I don't really care how it's happening as long as we're seeing this cycle. So that's the general framework that we're looking for. The next element is now we're going to get into a specific technique called incremental rehearsal. All right, so what is it? It's a practice activity that presents students a set of facts to practice containing a group of unknown facts and known facts. So I want to make this clear. When we say unknown, I'm not talking about they're not accurate. If we're at this stage, you're telling me they're already accurate, they're just slow. So unknown means they're not automatic. So if I give them 4 times 3, they're going to do a strategy, or they're going to take longer than 2 seconds, but they get the right answer. Unknown facts is they answer it immediately. So I just want to parse that out there. That I don't want the terminology to get mixed in. Unknown means they're accurate, but they're not fast, or they're not automatic. A known fact is they're automatic. What is it used for? Well, there's a fairly decent research base on this for sight words, vocabulary, simple math facts, letter or number names, any kind of factual information. This is how you want to do it. If your kids have to memorize the symbols for chemistry, this is how you would do it. If they need to memorize the state capitals in the states, this is how I would do it. This is how strategic learners practice things. How often? Again, we're looking at 4 to 5 days per week, 10 to 15 minutes maximum. 5 minutes, this can happen in 5 minutes, but we're looking across time. Now I have to point this out. You can't save up your 5 minutes from Monday, Tuesday, Wednesday, Thursday and do 25 minutes on Friday. That's not how it works. It's distributed across time. So this technique has been used in various content for various things, but we're basically talking about automaticity. So if you're a kindergarten teacher, you're not doing this with the addition facts. You might be doing this with number recognition, symbol identification. First grade, not really doing this with addition. Maybe you're doing this again with counting things, but second and third, fourth grade, this is where we're zeroing in. So there's 6 steps for this, but there's really, actually, it's really 3 steps that we're going to be focusing on. I'm going to go through each of these steps for setting this practice up. So the first step is the criterion for introducing the new fact or that unknown. So you're going to pick 3 to 4 facts that the kids will focus on that are unknown, not automatic. And you're going to mix it with 3 to 4 known facts. So what we're looking at is a 1-to-1 ratio, 1 unknown, 1 known, 3 to 3 or 4 to 4. What we don't want is 10 unknown and 2 known together. We want it to be balanced. Now, how do you determine the facts? So, what happened here? I'm missing a slide. Hang on, technical difficulty. Oh, I'm missing a slide. Hopefully it's in your handouts. So I need to go back here. I don't know if you have, I think I've deleted a slide by accident, but all right. So there's 2 ways to determine which facts to focus on. The first one is you can test every kid. So in other words, you call up each kid. So I call up Mark and I say, okay, Mark, we're working on your addition facts. And I show Mark every single fact. And any fact that he answers in 2 seconds or less is considered an automatic fact. Any fact that takes longer is not an automatic. But you have to do it individually with each kid. Or you could just use your best guess. So if I were to ask you, think about your kids that don't know their facts automatically. Which ones do they know? Which ones do they know? So usually they know their which ones. If you want to throw it in the chat, very good. So they know their zeros and their ones. Anything else? 2s, 5s, Tens, good. So yeah, perfect. That's exact. You guys are spot on today. I'm very impressed. So if you think about your set of facts, they are automatic with their zeros, ones, fives, and tens usually for sure. Twos as well. Those facts are the known facts. So in other words, they're automatic on those. I don't want to spend a lot of time. I'm going to use those to mix in. It's the other facts that they want to focus on. So you would pick the other facts. So let's say that we picked 4 times 3, 3 times 4, and yes, and 6 times 7. So the computer programs that you use, I'm not sure how Reflex Math does it, but on Extra Math, they kind of test the kids early on and they color code the facts by green, yellow, and red. Green is their automatic, yellow is their emerging, red is their not. So yes, same in the fact, yeah. So that's another advantage of the computer is that you get a lot of information. Same on Reflex. Okay, good. So you can pull from there. So let's say that you pick 4 times 3, 3 times 4, and 6 times 6. These are the facts that they didn't know. In other words, I showed them 4 times 3, and they started going 4 times 3. So 3 times 3 is 9. And one more 4, 10, 11, and one more 3, 10, 11, 12. Okay, they have a strategy. They got the right answer, but it took them a long time. Notice here that 4 times 3 and 3 times 4 are considered different facts. So I want to really point that out. Some teachers say, well, if they know 4 times 3, then they should know 3 times 4. That's a relationship activity. Here, I want them to know both automatically. So I don't want them going, okay, so 4 times 3 is 12. So 3 times 4 is the opposite. So the commutative property tells me that then 3 times 4 is 12 as well. That's a relationship. You've already done it. Now we just want them to know it automatically. So those 3 facts are going to show up 3 to 4 times in a practice session. So if you're doing flashcards, then you need to make sure that they're on 3 different flashcards. If you're making a worksheet, you need to make sure that it's on the worksheet 3 or 4 different times. Now, there are programs that do this. I'm pretty sure Reflex Math does it. So does the Extra Math, have it set up this way. And so does Rocket Math. Then facts that they know are kind of mixed in there at 3 of them. So that's this stage. Step 1 and 2 are the most critical parts to this, is that you target a set and then you give them multiple opportunities to practice each set. So 4 times 3 is going to be there multiple times. And that's the key with this. Far too many practice activities only have each fact 1 time. That in my opinion is the fundamental flaw with a lot of what's happening with games. All right, let's kind of let you guys process that a little bit, because these are the 2 key steps. So as we get to cover, copy, compare, you would apply these to cover, copy, compare as well, is the chunking. This is the chunk. Are there any questions on this? There certainly has to be a question. You can either unmute or put it in the chat box. To me, this is the key practice feature, is that you want a small chunk that is repeated multiple times. So obviously this can be done with flashcards, but worksheets can be built in this way. Can you make a game that's set up like this? You probably could. Then the third step is we have a cycle that's occurring. So as they become automatic, you add some new ones. And then you add some new ones, but you also begin to take some away. So you have a cycle that goes across time. So as students demonstrate automaticity, You then add in some other facts. So the unknown facts begin to become known facts, and we have a cycle. Yeah, so Julia's question in the chat, so you would basically go over 8, yes. So if you pick 4 unknown facts, you would pick 4 known facts. Now you could also do 3 unknown and 3 known. But yes, 4 unknown, so there'd be 8 facts, but each of those facts would be on multiple cards, or they would have multiple opportunities. So Melissa has another good question. You guys have got some great questions today. So should we focus on one fact family at a time? So I'm going to answer it 2 ways. Research has done it by fact family, so that's an option. And they've also done it randomly. I would do it randomly. So I don't know if that's because I'm more of a middle school and high school teacher, where I'm sort of past the progressions where they just need to know them. I would pick it randomly, but you could definitely do it by fact family. Absolutely. What I would avoid doing is we're just going to do all the 1s today. Then we're going to do the 2s today. Then we're going to do the 3s today. To me, that doesn't make sense. I would either do the fact family piece or random. So when I say random, I mean you just pick 3 facts randomly from the whole set, and then those are your target facts, and then you pick the ones they know and mix in there. Yeah, so okay, another good question. So Stephanie's question is, so once they learned it, does it stay? Yeah, so yes, for the short term. So once they know it, then that sort of becomes a known fact for a little while, but eventually you start to get rid of those as well. So you don't remove it immediately. It's a gradual release. Did that answer your question, Stephanie? Perfect. So these 3 steps are the critical features to bridge kids from relying on strategies to becoming automatic. And this is what's not built into our programs. Now, some have tried. The Eureka Math folks in here, are the sprints set up like this? That's the question you want to ask yourself. Are they set up like this? I think they're close to this, but they're not quite like this. They're more random, in my opinion. All right, so those 3 steps, what you're hitting is multiple opportunities, targeted facts. Now, feedback isn't yet in here. Feedback will occur when we're practicing. Then, so here's sort of a visual image. I know your slide in your handout is probably small on this, but here's kind of the visual. So here is the first set. So there are 3 unknown facts mixed in with 3 known facts. I did 3. And each one is on 3 different cards. So there's a total of, oh my gosh, my math is losing, 18 cards that are randomly mixed up that the kids are going to practice through. So they're practicing this. Now, you can get even more specific. I like the random practice, but you can even get more specific where you set it up specifically for the first round, that they have 1 unknown followed by a known. Then they have another unknown followed by 2 known, and so forth. This is trying to leverage behavioral momentum. So that's kind of a push where you give them 1 that they may struggle, that's hard, and then 2 that they know. So they start to build momentum up versus random. So either way, you can do it randomly mixed in, or if you really want to try to leverage this behavioral momentum piece, you kind of set it up this way for the first round. Maybe an interventionist is doing it like this when they have 5 kids, but if I'm a 3rd grade teacher having my kids do this, that's going to just get to be too much when I have 25 kids in my room. But either way, what we're looking for is sort of a mixture piece. The below part of this screen is leveraging behavioral momentum. Now, here is what the cycle that was a couple of questions were asked. So the kids have been practicing this for 3 or 4 days, and you're starting to see, oh, they've got the facts. So in other words, you see 4 times 3, 3 times 4, and 6 times 7. All of the kids are answering it automatically. So now it's time to go to the next set. So what happens is, you see right here, let me go back here. So these facts here are going to move down here. And then you're going to pick a new set. So here's the 3 new ones. And then you've mixed in the ones that you had just been practicing become the known facts. The other ones are still in there. But eventually, after a couple of cycles, you start to get rid of the known facts. But that's generally, in my opinion, that is not what's happening with practicing of math facts. We're tending to practice all of them. We're not really saying, okay, they know this one, they know that one, we're going to target this chunk. Once they get this chunk, we're going to add another chunk. That's the level of specificity that's not happening.
So Paul, there's a question in the chat box about once they are known facts, like 4 times 3, do you keep that 4 times 3 on 3 separate cards? And when you're moving it to the known column? So
yes, this is where it starts to get, this is where it starts at research meeting, like the practice reality of a classroom. I like just to move them right into the known and keep them on 3 facts. Then a little bit later, drop out a couple of the cards. You slowly get rid of the cards. I just like to move them all into that. Now, there's some flexibility there, so I don't want to say it's an absolute. What is an absolute is you don't just drop them. How you drop them, I kind of leave that up to you. You're professionals. You can make that. I think you can make that decision. Now, remember, I'm kind of talking like everybody's moving. We all know that's not reality, right? So sometimes some kids are moving faster than others. You can manage it a little bit. Usually 3 groups tend to emerge in a general classroom with 25 kids. Is 3 move really fast, 3 are kind of fast but not as fast, and then 3 are a little bit. So you end up with kind of 3 groups. So essentially you kind of have 3 different practice sets happening at once. Don't go more than that. Don't try to do individual students. Now, if you're an interventionist, you can do a little more individualized because you don't have as many kids at one time. All right, so those are the key pieces. Now, like I said, 5 to 10 minutes a day. In a general ed classroom, I'm looking at 5. An interventionist, maybe up to 10, but no more than that. This could be morning routine. It could be a transition if you're in elementary school. So it doesn't have to be out of your allocated math time. There's other times this could happen. You want to try to keep some records. So most teachers will have like kind of a class list, and they'll record what facts the kids are practicing and kind of check off as they go. The other thing is motivational procedures. The big thing with this is you want to reward progress, not the end point. Too many times I see a bulletin board on the back of the room that has the 30 plus club or 40 plus club, and you only get your name on up there if you get 30 or 40. Well, kids with learning disabilities may never get there, but they're still growing. So you want to reward growth. So every time they move to another set of facts, reward that. That's how we encourage it. So like my daughter, she was in a room where they were only rewarding that 40, and she never got that 40. So very quickly, math for her and fact practice was a very negative experience because she was at 10 or 15 and the rest of her classmates were at 30, 40 getting all the awards, even though she's working twice as hard, but not making the progress. Reward the growth. I really can't emphasize that much. Reward the growth. Even if it's one fact in a week that they grew, reward that growth. Because I saw with my daughter how negative an experience that became. Melissa gave me 100% yes, so I'll take that as an endorsement of what I just said. All right, now, what I want us to do now, all right, good. We got about, do we want to do this now? No, I'm gonna let these three, this is a natural place to stop. I'm gonna let these 6 steps, but really these 3 steps kind of set in tonight and overnight. And really tonight, what I really want you to do is think about these 3 steps here. We haven't got to the feedback piece. We'll do that tomorrow. But I really want you to think about these 3 steps in relationship to what you're doing. Remember, these are helping kids go from fluency to automaticity. This is not understanding or relationship or beginning fluency activities. These are, you've said, my kids are accurate and they've got some strategies. I'm trying to get them to this automaticity piece. So I really want you to think about these 3 things, because in my opinion, this is where our practice is going askew, is that we're not doing this kind of targeted practice. We're kind of just doing mass practice. Targeted practice, again, there's a variety of ways you can do this. I just think games are harder to make fit this. They're better at really in that relationship and fluency stage. So with that said, I'm gonna close out my comments. I'll hang out if anyone has any specific questions that maybe they want to ask. When we come back tomorrow, we'll pick up here. Just a little hint to you. I'll probably give you a little practice test retrieval quiz tomorrow. I'll weave in a retention strategy to see how you retain this information, and then we'll get into the other strategies here. But I'll hang out here if anyone has any questions on anything I talked about today. I really hope my goal today was to really solidify the cognitive rationale for fluency, and then those four stages in the progression, and begin to talk about how. So we're now getting into the how we help kids develop automaticity.